Alright, so carrying on with recurrence relations. A recurrence relation is a mathematical rule that we can use to generate a sequence. It has two parts, a starting point and a rule. Once again, the rule should be shown here, which is t0 is equal to a. For example, the sequence 10, 15, 20 can be written as follows. You start with 10 and you obtain the next term by adding 5 to the current term and repeating the process. So this is the rule that you could use. Now there's a couple of things I need to address. One, the tn and the constants that the variables that you use here are interchangeable. So if you ever see this with an a, or you see this with, for example, a different variable, it's okay. Just as long as you've got that same form, that's the whole point in this whole recurrence relation structure. When you've got v0 or vn, you can see it doesn't really matter, just as long as it is consistent. So if the question asks you for an, you would need to use an here. But this question says let vn be the actual terms. Same thing. So vn is the same as what you would usually do. So the first question says write the first 4 terms of the sequence, which is defined by the recurrence relation v0 is equal to 100, where vn plus 1 is equal to vn minus 9. So this is saying the starting point is 100, as you can see there. And the next term, so v0, v1, v2, to work out these terms, you have to minus 9. So this is 100 minus 9 will give you 91. That's the value for v1. Okay. Then you use this answer, 91, to take away 9, and you'll get 82. So it becomes that machine, as you can say. Okay, so I'm going to show you the next question. And this one here will work together. So I'd like you to pause at this point. See if you can work out how to actually work out the sequence for this. Pause this video, and in about 3 seconds or so, we'll do the solution. So write the first 4 terms of the sequence defined by the recurrence relation v0 equals 20. So we need to start off with v0 is equal to 20 and understand what this rule is asking us to do. So this rule is asking us to times it by 2 or multiply it by 2, and then once you get the particular value, take away 1. So let's do that. What's 20 times 2 minus 1? So 20 times 2 is 40, take away 1, which is equal to 39. Okay, so v1 is equal to 39. Again, we have to take this particular value, so 39 times 2, okay, minus 1. Okay, so 39 times 2 is 78, take away 1. v2 is equal to 77. Okay, v3, to work out v3, we need to go do exactly the same thing, 77 times 2 minus 1. Okay, 77 times 2 is 154 minus 1. Okay, so that'll give us 153. And let's work out v4. Okay, so v4, 153 times 2 minus 1. So 153 times 2 is 306. Take away 1. 305. Now, we have to be very careful with this particular question as well, because it does say write the first 4 terms. So technically, the first 4 terms of the sequence would be v0, v1, v2, v3. The reason why I've gone to v4 is that generally you won't be penalized if you go up to v4. Unless, of course, they probably would ask the question in a way where it says state v1, v2, v3, v4. Okay, so generally the first 4 terms are these 4 terms here. So there's a quick way on doing this on CAS, because you can see if you've got nice numbers and you're quick with numbers, this doesn't become too much of a tedious process. But the last thing you want to be doing is spending all that brain power calculating numbers. Rather than, you just want to know the actual process. On your CAS, you need to input the starting number, V0, then press enter. So I'm going to just split this screen for a moment. Okay, so on the CAS, you need to input the starting number, and the starting number that we have is 20. So you're going to start a calculator page, type in 20. Now from this point, you don't press anything else apart from enter. Okay. Now it says enter the recurrence relation and then press enter. But instead use answer instead of the value for V0. So what this is saying is you would go times 2. That's all I pressed. I didn't type in answer. All I did was just type in times 2 minus 1. Okay. For those of you that want to do it using typing in answer, you just need to type in 2 times control negative and then minus 1. You can see it's in that form where you get 2 times Vn minus 1. And then from this point, you just press enter, 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 enter. Okay. And the sequence is generated for you on the CAS. Alright, so try it yourself. Pause the video at this point, see if you can work out the sequence by hand and also by CAS. In a moment, I will work out a couple of these for you guys, but I won't work out all these, I'll work out a couple of these. So pause the video at this point, work it out. Alright, so just to save time on this video, I want you to make sure that you understand how to do this by hand. So if you have forgotten how to do this by hand, go back to the previous example. But just to save time, I will do this on the CAS. So the first one here says Rn plus 1 is equal to Rn plus 5, where R0 is equal to 10. So the starting value is 10. And on the CAS, that's exactly what you should type in, the starting value, 10. And then you press enter. From this point, you type in whatever the recurrence relation or the rule that you're asked to generate is. So plus 5. So all I'm going to do is type in plus 5. I'm not going to type in answer. You can type in answer if you'd like. So answer plus 5. And then you press enter 5 times because it's asking for the first 5 terms. Or you can press it 4 times if you go back to what I said before. 1, 2, 3, 4. And so now you've generated the sequence 10, 15, 20, 25, 30. So 10, 10, 15, 20, 25, 30. Next one, I'm going to leave that one for you to do because it's just a minus sign. Let's do something that's a little bit different. So we've got 3. So type in the starting value, which is 1. And then what you need to do from that point is go 3 times your answer. So 1, 2, 3, 4. Let's see, you get the sequence 1, 3, 9, 27, and 81. Okay, I'm going to do this last one here, E. Once again, just follow that idea. Type in your starting value, 11, and then you're going to go 5 times your answer plus 3. And then enter 5 times 1, 2, 3, 4, 5. And so you get your sequence, which is 11, 58, 293, 1468, and 7343. Okay,